Okay, so welcome to this naest webinar series. As you know, naest is our national Anveshika experimental skill test, and we conduct it every year. You must have read from the website all the details, and many of you have already registered in that, so you know all these things. Now, this is an experimental skill test, and why we are focusing on experiments? So, we are focusing on experiments because the whole development of physics starts always with some kind of experiment. जितनी भी आपने थ्योरीज देखी होंगी, सुनी होंगी, पढ़ी होंगी, अभ्यास किया होगा, सभी चाहे वो कितने भी बड़े थ्योरेटिशियंस रहे हों, लेकिन वो सभी थियरीज किसी न किसी एक्सपेरिमेंट से ही निकलती हैं। और इसलिए जो एक्सपेरिमेंट्स हैं साइंस में और फिजिक्स में तो और भी, वो सबसे मूल में है। एक्सपेरिमेंट्स आर द सोर्स ऑफ डेवलपमेंट। यू थिंक ऑफ एनी काइंड ऑफ theory that has been created, all start with some kind of experiment. So in today's talk, I'll be talking of a few such theories and the connection between the theory and the experiment. So let's go to slide and hope you will enjoy this particular session. All right, so our first slide is title, Role of Experiments in the Development of Physics. And if I look at the next slide, it gives me, okay, how do we go to the next slide? This is also an experiment. All right, this is also an experiment. Yeah, so this is the connection between experiments and theory. If you look at this slide, we have two blocks, experiments and theory, and you can see two arrows in two opposite directions. From the theory we are going to experiment. There is an arrow, that outer blue line, and then from the experiments we are going to the theory, that is the inner blue line, and then both of them finally result in the development of physics. तो एक्सपेरिमेंट्स से थियोरी निकलती है और थ्योरी से नए एक्सपेरिमेंट्स निकलते हैं। दोनों तरफ से रिश्ता, दोनों तरफ से है, आग दोनों तरफ से बराबर लगी है। कोई भी थ्योरी बनती है तो क्यों बनती है? वो थ्योरी बनती है क्योंकि कुछ एक्सपेरिमेंट्स किसी ने किए होते हैं, या तो वैज्ञानिकों ने किए होते हैं, हमने हमारी प्रयोगशालाओं में होते हैं, और नहीं तो प्रकृति ने किए होते हैं। जो नेचर में जो कुछ हो रहा है, हमारा दिन रात होना या सूरज चांद चमकना, ये सब कुछ जो कुछ नेचर में हो रहा है, वर्षा का होना, लाइट का आना, स्कैटरिंग होना, आसमान का ब्लू होना, समुद्र के पानी का ब्लू होना, ये जितने प्रकार की चीज़ें हो रही हैं, वो भी एक्सपेरिमेंट्स हैं, वो प्रकृति के द्वारा किए हुए एक्सपेरिमेंट्स हैं। So all those experiments which are done either by the nature or by people. So कुछ ना कुछ ऐसा एक्सपेरिमेंट हुआ है जिससे कि वो थियोरी निकल करके आ रही है। अभी उसका उदाहरण दूंगा मैं आगे के स्लाइड्स के अंदर में। और जब एक्सपेरिमेंट्स, जब हमारी हम जो जानते हैं, the things that we know, the theories which are already developed, if they are not enough to explain those experimental results, हमें कुछ ऐसा मिलता है जो कि हम जो थियोरी जानते हैं, जो हमने बना रखी है अभी तक, उनसे नहीं काम चल रहा है, then we create new theories. So that is how new theories are created. It is all inspired by experiments. But once the new theory is created, the theory makes its own predictions. Once the theory is there, you can do mathematics, you can do a lot of calculations, and you can predict things. और आप जब प्रेडिक्ट करते हैं, देन द रोल ऑफ एक्सपेरिमेंटलिस्ट अगेन स्टार्ट्स. द एक्सपेरिमेंट इज नाउ इंस्पायर्ड बाय द थियरी. The theory has predicted something, and then to verify that whether the predictions are right or not, new experiments are designed. And when new experiments are designed, either they will conform to the newly developed theories or they will reject it. जब भी कभी नई थ्योरी आएगी तो उसके साथ में कुछ जरूर नए प्रेडिक्शंस होंगे, और उन नए प्रेडिक्शंस को वेरीफाई करने के लिए आपको फिर से वो करना पड़ेगा, एक्सपेरिमेंट्स नए डिज़ाइन करने पड़ेंगे. तो ऐसा करके वो दोनों का रिश्ता चलता है, एक्सपेरिमेंट से थियरी और थियरी से एक्सपेरिमेंट से चलते हैं. और हम देखते हैं थोड़े उदाहरण लेकर के अगले स्लाइड के ऊपर. न्यूक्लियर मॉडल ऑफ एटम सब लोग जानते हैं. यहाँ बिल्कुल बचपन से हमें सिखाया गया है क्लास 8-9 वगैरह से कि जो एटम है उस एटम के अंदर में पॉजिटिव चार्ज रहते हैं और न्यूक्लियस जिसको हम कहते हैं, और वहाँ के उसके बाहर फिर इलेक्ट्रॉन्स होते हैं. इसको हम लोग न्यूक्लियर मॉडल ऑफ एटम कहते हैं. और किसने इसका आविष्कार या इसकी खोज या किसको कहा जाता है कि इन्होंने इसको डेवलप किया, वो एक रोचक कहानी है. लेकिन पहले हम आपको थोड़ा ब्लैक बोर्ड के ऊपर बताएं कि ये न्यूक्लियर मॉडल ऑफ एटम है क्या चीज़ ना. यद्यपि आप सब लोग यू ऑल नो व्हाट दिस न्यूक्लियर मॉडल ऑफ एटम इज, बट स्टिल let's look at the board. So the whole idea is that the atom is this big. That means this whole volume is the volume of the atom as such. But then the atom has positive charges, protons, neutrons, which are confined in a very small space which we call nucleus. And then the electrons keep wandering here and there around it. So normally up to whatever distance the electrons go, that whole thing is atom, and here is the nucleus, and then the electrons are moving in this whole volume. So this was in 1909. It's a very interesting story. बहुत मजेदार कहानी है ये. 1909 ईयर, दो सज्जन, अभी स्लाइड पर उनकी तस्वीरें भी मैं दिखा दूंगा, गाइगर साहब और मार्सडन. ये जो दोनों हैं, इन दोनों ने एक एक्सपेरिमेंट किया. और क्यों किया? रदरफोर्ड साहब की लेबोरेटरी के अंदर वो एक्सपेरिमेंट हुआ. आपको बहुत जाना पहचाना है वो एक्सपेरिमेंट, आपको बहुत जाना पहचाना है. उसको कहा जाता है पॉपुलरली गोल्ड फॉयल एक्सपेरिमेंट. अल्फा स्कैटरिंग ऐसा बोलते हैं. So the popular version which is given in textbooks is that Rutherford's alpha scattering experiments. That is how also it is named. So there was some sheet, some metal sheet, gold foil. ऐसे ही लिखते हैं ना, gold foil. And then alpha particles. What are alpha particles? Alpha particles are 2 protons, 2 neutrons packed in a very tiny volume. A nucleus of these 4 particles, 2 protons, 2 neutrons, that is known as alpha particles. So it is positively charged, 2 protons. And this alpha particle is sent, is bombarded on this gold foil, and one after the other, one after the other, one after the other. Most of them go on the front. They come out of this foil, but some of the alpha particles, they also reflect back. And it said that is something like 1 in 10,000 of that order that back scatters. It comes in the same direction from which it is going. तो ऐसा वर्णन करते हैं कि वो गोल्ड फॉइल के ऊपर ढेर सारे अल्फा पार्टिकल आप डालते जाओ, और फिर डिटेक्टर लगा के खोजो, यहाँ निकला कि यहाँ कितना निकला, 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 and then they find that something like one alpha particle in 10,000 they are back scattered, same side में वो आते हैं जिस साइड से वो भेजे जाते हैं. So this is known as Rutherford's alpha scattering experiment और gold foil experiment. और यहाँ से इस एक्सपेरिमेंट से न्यूक्लियर मॉडल की थ्योरी का जन्म होता है. बट लेट मी टेल यू द स्टोरी, हु इज दिस पर्सन गाइगर एंड हु इज मार्स्टन. रदरफोर्ड वाज अ प्रोफेसर, उनकी अपनी लैब है बहुत बड़ी सी जिसमें बहुत तरीके के काम हो रहे हैं. और ये जो हंस गाइगर है, ही इज रिसर्चर, रिसर्च फेलो और जूनियर फैकल्टी आप कह सकते हैं. ताजा ज्वाइन किया था 1-2-3 साल पहले. एंड दिस मार्स्टन इज बीएससी स्टूडेंट. और यूनिवर्सिटी के नियम के अनुसार हर किसी को बीएससी की डिग्री लेने के लिए एक एक्सपेरिमेंटल प्रोजेक्ट करना है. So everyone is supposed to do some kind of research experiment and then submit the results, thesis. So Marsden approaches Geiger for guidance, and Geiger talks to Rutherford, who is the boss, जिनकी laboratory में सारे काम हुए. And Rutherford just suggests Geiger that okay, do these kind of experiments. We all know by that time no one knew that some particles are also coming back. So Rutherford suggested that we have done enough, so many experiments by putting detector on the front side. So just to give this BSc student some flavor of research, ask him to put the detector this side so that he will just learn how to do the experiment. So that was the idea with which this experiment was planned. ऐसा नहीं था कि कोई न्यूक्लियर मॉडल को खोजने के लिए इस एक्सपेरिमेंट को किया गया था. It was not. This experiment was performed just to give this student Marsden some kind of research exposure, ताकि वो अपना सबमिट करके और डिग्री ले सके. Alright? So that is how these two people performed the experiment. But when they performed the experiment and looked at if any alpha particle comes this side, which was not the target of the experiment, nobody thought that we will be getting some alpha particles, लेकिन मिले उनको alpha particles. लेकिन वो एक जो मिल गया 10,000 में एक, इस फ्रैक्शन में जो मिल गया, वहां से कहानियां अब अलग हो गई. Because the existing models, the theories which were prevailing that time, the Thomson's model, in which Thomson has also done a lot of experiments in the laboratory. And from those experiments only he had created this theory that all the positive charge is distributed in the whole of the atomic volume, and then the electrons are just fixed here and there in this. And he has done a lot of calculations to show that yes, this is possible, Thomson. But now this particular observation of the experiment, this theory could not tell कि ये कैसे हो गया. तो अब नई थ्योरी का जन्म हो रहा है. That is how experiments lead to new theories. Now Rutherford works on this data, the experimental data that Geiger and Marsden have obtained, and from there he took some 2 years or so to develop what we call this theory, nuclear model of atom, and then he derived lots of equations for scattering, and those expressions, those formulae, those equations we are still using in material science research. So that is how from experiments new theories are created. तो हम अगली स्लाइड पे जाएंगे, थोड़ा इसके आपको इसके पिक्चर दिखाते हैं. तो ये गोल्ड फॉयल एक्सपेरिमेंट किसने किया? हु परफॉर्म्ड द गोल्ड फॉयल एक्सपेरिमेंट? आई टोल्ड यू. नेक्स्ट स्लाइड पे चले. Yeah, these are the people. On the extreme right, you have Rutherford, and in the middle you have Marsden. You can see the young boy, and on the left you have Geiger. Yes, and this is the kind of apparatus they use to do the experiment. It is not the kind of experimental setup that you see in your textbooks. The actual experiment which was performed is very different from the perception we get from our textbook descriptions. All right, so this result that one of the particles or few of the alpha particles bounce back in the same direction was a great surprise to Rutherford, because the existing theories could not explain this, and therefore this nuclear model was created. And this is the paper that Rutherford writes, the scattering of alpha and beta particles and the structure of atom. इसकी और भी कहानी है, थोड़ी सी चर्चा और करेंगे, फिर हम नेक्स्ट एक्सपेरिमेंट्स पर जाएंगे. एंड yeah, this is another title in our textbooks. What is the limitation of Rutherford's model? Okay, and then we say that the Rutherford model has a limitation that if the electrons move in circular orbits, then they are accelerated and they should radiate energy. अगर इलेक्ट्रॉन्स मूव करेंगे, अगर इलेक्ट्रॉन्स फिक्स नहीं है जैसा कि थॉमसन के मॉडल में था, अगर इलेक्ट्रॉन्स न्यूक्लियस के बाहर है, खाली जगह में है, तो उनको मूव करना पड़ेगा, और अगर वो मूव नहीं करेंगे तो न्यूक्लियस में गिर ही जाएंगे, और मूव करेंगे तो भी गिर जाएंगे, क्योंकि अगर मूव करेंगे तो वो एक्सेलरेशन में होंगे तो एनर्जी रेडिएट करेंगे. ये दूसरे थियरीज हैं, मैक्सवेल साहब की बनाई हुई थियरी है ये, कि कोई भी एक्सेलरेटेड चार्ज पार्टिकल जो है वो एनर्जी रेडिएट करता है, तो उसके अनुसार ये एनर्जी रेडिएट करेंगे और फिर से गिर जाएंगे स्लो हो करके. तो ये पजल है, और इसलिए रदरफोर्ड के मॉडल की ये कमी है. तो मैं उनके पेपर से ये पढ़ रहा हूँ, जो आपके इसमें लाल से दिख रहा होगा आपको. द क्वेश्चन, रदरफोर्ड लिखते हैं अपने रिसर्च पेपर के अंदर में, द क्वेश्चन ऑफ द स्टेबिलिटी ऑफ एटम प्रपोज्ड need not be considered at this stage. For this will obviously depend upon the minute structure of the atom and on the motion of the constituent charge parts. तो इन्होंने शुरू में ही कह दिया है कि हम इलेक्ट्रॉन की स्टेबिलिटी पर कुछ भी नहीं बोलेंगे. हमारा रिसर्च इसी पर है कि इलेक्ट्रॉन्स और प्रोटॉन्स, न्यूट्रॉन्स ये थोड़े अलग ढंग से सजे हैं एटम के अंदर में. जो प्रोटॉन्स न्यूट्रॉन्स हैं वो एकदम छोटे, बहुत ही छोटे, समझो कि 1,00,000 गुना कम रेडियस के अंदर में, एटम का जितना रेडियस है उससे 1,00,000 गुना कम रेडियस के अंदर में सारे प्रोटॉन्स और न्यूट्रॉन्स हैं, और इलेक्ट्रॉन जो है वो बाकी के पूरे वॉल्यूम के अंदर में अलग से हैं, बाहर हैं. तो ये हमारा मेन रिसर्च है जो इस पेपर के अंदर में प्रेजेंट किया जा रहा है. अब वो इलेक्ट्रॉन्स स्टेबल हैं कि नहीं, क्यों स्टेबल हैं, और कैसे उनका हो रहा है, ये इनका विषय नहीं है. तो जिस चीज़ को इन्होंने अपने थियोरी के अंदर में छुआ नहीं, उसके लिए हम लोग उनको दोष देते हैं कि उनकी मॉडल की ये खामी है, ये कमी है. दिस इज द लिमिटेशन ऑफ रदरफोर्ड्स मॉडल, वेयर द थिंग इज दैट he has not addressed this question in this research paper. And what he has made the model, that the nucleus is inside, positive charge is in a tiny volume, and electrons are outside this nucleus, that is still there. उसमें कोई limitation नहीं है. So it's injustice to Rutherford that we say that limitations of Rutherford. तो हम और आगे चलते हैं, अगले एक्सपेरिमेंट्स की स्लाइड देखते हैं कि क्या है. ये आइंस्टीन की का जो स्पेस टाइम का मिक्सिंग है, स्पेशल थियोरी ऑफ रिलेटिविटी और जनरल थियोरी ऑफ रिलेटिविटी, उसके ऊपर अगले वेबिनार के अंदर में चर्चा होगी, अगले सैटरडे के समय में. और इसलिए मैं अभी उसके ऊपर ज़्यादा नहीं कर रहा हूँ। लेकिन ये भी किसी न किसी एक्सपेरिमेंट से निकला है। अगले सैटरडे को जरूर ज्वाइन कीजिएगा और पता करिएगा कि कौन से एक्सपेरिमेंट से आइंस्टीन की रिलेटिविटी की थियोरी निकली है। क्योंकि आइंस्टीन ने खुद बहुत कम एक्सपेरिमेंट्स किए हैं, लेकिन किसी एक्सपेरिमेंट के रिजल्ट से और फिर आइंस्टीन की ये थ्योरी निकली है, और आइंस्टीन की थ्योरी के बाद बहुत सारे एक्सपेरिमेंट्स उससे निकले हैं। ये सारी कहानियां जो है वो आपको अगले सैटरडे के नेस्ट वेबिनार सीरीज के अंदर में सब कुछ देखने को मिलेगा। हम आगे बढ़ते हैं, आगे बढ़िए, आगे बढ़िए, आगे बढ़िए, और आगे और आगे और आगे। हाँ, ये क्या है? क्वांटाइज्ड इलेक्ट्रॉन ऑर्बिट्स। अब ये फिर से उसी न्यूक्लियर मॉडल के ऊपर बात आती है। हम ब्लैक बोर्ड पर जाएंगे अभी। इसकी कहानी जानने के लिए ये क्वांटाइज्ड इलेक्ट्रॉन ऑर्बिट्स क्या बना है। जो हम कहते हैं कि न्यूक्लियस के अंदर पॉजिटिव चार्ज है, रदरफोर्ड मॉडल, then the electrons are also, they have to be somewhere, and if the electrons are here, they must move so that just like our earth moves around sun, otherwise the gravitational force will just pull it there. So the electrons must go in some kind of elliptical, circular, bound orbit. But then as I said, this also demands, or Maxwell's theory demands, that this should radiate. But then the experiments are always supreme, because theories are created by us, and the experiments which are happening, these are the phenomena which are happening. We are doing our equations, we are writing theory on our notebooks, but these are the things which are happening, and the things which are happening, that has to be honored. So the electrons are not radiating energy. If they radiate energy, they will fall. और ये भी सही है, रदरफोर्ड के एक्सपेरिमेंट से एकदम पक्का कि न्यूक्लियस अंदर, इलेक्ट्रॉन बाहर, and if the electron is outside, it has to move in some kind of bound orbit. So what happens? A new theory takes birth, and that is Niels Bohr. Bohr's model. Now Bohr has just taken it from Rutherford's theory that yes, the nucleus is there, electrons are outside, but then why don't they radiate? And he says that okay, we have to modify the theory, and the theory is modified. How? He says that okay, we have to add to our theory. That is how the experiments create theories. So the Bohr says that all right, if there are some special circles of some special radii, there are some special circles of some special radii, and which are those in which the angular momentum is mass times v times r is an integer times what is known as Planck's constant divided by 2 pi. All right. This Planck's constant, Max Planck is another great scientist who has developed an excellent theory for radiation, and Planck's theory radiates from some other experiment, right? That I will not talk today. So all the theories and experiments, they are all driving each other. All right. So the Planck has already done a lot of research, and from there this constant, which we know as Planck's constant, is a fixed number, and the dimensions are of angular momentum. So integer times this Planck's constant divided by 2 pi, that is, if that is the angular momentum of the electron, it will not radiate. It will defy Maxwell's equations. Maxwell's equations will not be applicable, because new theories are created. You cannot ask that why it is not applicable. Maxwell equations, those theories are developed, but they cannot explain this. So new theory is being created, and this new theory is telling that if this is the case, then it will not radiate. So that's known as Bohr's model. Although if you go in the original research article of Bohr's, he does not do it this way. He does it in some different way, in some talk, maybe I will talk about that. But this is how. So see the connection between theory and experiment. The theory shows that the electrons are stable. The theory shows that the experiments are stable, and the experiments, the event shows that hydrogen atom is stable. The electron is not falling, it's not radiating, and therefore the new theory is created. But once the new theory is created, which ultimately becomes quantum mechanics, a whole lot of new experiments are planned and a whole lot of engineering applications are done from there. Okay, so let's this is the experiment for which led to Bohr's theory or the whole quantum mechanics. I will say one of the important experiments, hydrogen spectrum. If you take hydrogen in some tube and then pass electricity, high voltage, do vacuum and all those, and then measure the wavelengths of light emitted by that hydrogen, you find in visible region a red light and a green light and blue light and violet light. Some 4 different colored colors are seen in that hydrogen spectrum, and this was measured by someone else. This was measured by the next experimentalist, that the person is Angstrom, not Neil Angstrom, which went to moon. This is Angstrom, who had measured those wavelengths of from solar radiation, in fact, and from there people measured experimental results that okay, these are the wavelengths, these are the 4 wavelengths which are emitted by hydrogen. And those 4 wavelengths that created once again this theory, Niels Bohr's theory, that if that angular momentum quantized orbit you see, you assume, then you can explain those 4 wavelengths. So that is how this has come. Yeah, next. All right, wave particle duality of light. This is another extremely interesting story. So, right, so light, wave or particle. It's a very difficult concept to grasp, to start with. But once you get the feel of it, it's very, very interesting. And the answer to this is that question is illegal. This question is illegal. But to reach this answer, so many experiments and so many theories have been developed. As you all know, the story starts with Newton, who did a lot of experiments on this light, and all those experiments are in his book Optics. C or not C, but K is very much there, Optics. So he does a lot of experiments with light, mostly sunlight and sometimes artificial light. And then from those experiments he develops a theory where so-called corpuscle light is made of particles. लाइट जो है वो कैसे बनी है, उसके क्या कंस्टिट्यूएंट्स हैं, छोटे 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 कण हैं और रंग बिरंगे, हर एक रंग के लिए एक अलग किस्म का कण है. And then these obey normal Newton's laws of motion. And from there he explains all kinds of experimental results which were available that time. Reflection, refraction, dispersion, वो सारी चीजें इनके इस पार्टिकल मॉडल में से निकल करके आती है. He is able to explain all those phenomena which were available. But then there were some experiments जो कि इसमें भी है, ऑप्टिक्स के अंदर में भी है, and that is on polarization. These are wave aspects. Polarization है, diffraction है, Not that Newton did not know all these interference. These are all wave we understand now today through wave theory. But Newton had done some experiments and he had seen these things. Newton's ring is a very famous experiment which we do in our BSc syllabus in many of the universities and colleges. That is a purely an experiment which is based on interference of light. Today we understand it by wave theory and not the corpuscular particle theory. But Newton had developed equations and theories in terms of these particles, corpuscles, which could explain all those experiments there. And then, as you know, Huygens, who was contemporary, so Huygens was not convinced with this particle theory. He developed wave theory. Wave theory also was able to explain all this diffraction and interference and reflection and refraction and everything. All right, so both the theories were able to explain the experiments. But prediction. Now comes predictions. Something for which no experiment is available and the theory is predicting. And then the experimentalist will do the experiment to confirm or reject. And that was speed of light in medium. Now, if you go by the Newton's theory in terms of particles, where light is considered to be made of tiny particles not interacting with each other but interacting with the material on which light is falling. तो ऐसा अगर आप सोच कर चलोगे कि लाइट जो है, जैसा न्यूटन ने सोचा और थियरी डेवलप किया कि लाइट किससे बनी है, तो उसके छोटे छोटे कण जो आपस में तो नहीं इंटरेक्ट करते हैं, लेकिन जिस पर पड़ते हैं, जिस मटेरियल पर, उससे इंटरेक्ट करते हैं। वहां से सारा उन्होंने चीजें निकाली। अब उस थियरी से प्रेडिक्शन किया कि अगर हम एक पानी में या कांच में या कैसे इस तरह के ट्रांसपेरेंट मीडियम के अंदर में लाइट को लेके जाएं और उसकी स्पीड नापें, तो दैट स्पीड विल बी ग्रेटर देन स्पीड इन एयर। ये प्रेडिक्शन है। और जो हाइगेंस का थियरी है विच वाज इन टर्म्स ऑफ वेव्स, सो दिस इज प्रेडिक्शन फ्रॉम न्यूटन्स थियरी or particle theory. Let me call it particle theory. Then the wave theory, that can also predict, and that prediction is opposite to this. That prediction is opposite to this. This thing becomes this thing. So speed of light in a medium should be smaller than speed of light in air. That is prediction from wave theory. We are calling it prediction. हम उसको prediction कह रहे हैं, भविष्यवाणी कह रहे हैं, क्योंकि एक्सपेरिमेंट्स अवेलेबल नहीं थे। तो अब इस थियरी के प्रेडिक्शन के कारण से वो हुआ कि नापो स्पीड ऑफ लाइट को, नापो पानी में, कांच में नापो। और फिर बहुत सारे एक्सपेरिमेंट्स हो करके और माइकलसन, फोको सब लग करके और लोगों ने सारा सिस्टम डेवलप किया और उन्होंने पाया कि हाँ, अगर मीडियम में चले जाते हैं तो जो स्पीड लाइट की है वो घट जाती है। तो वहां से फिर एक थ्योरी रिजेक्ट होती है और दूसरी थ्योरी आती है। सो दैट इज हाउ फ्रॉम एक्सपेरिमेंट्स वी चेंज आवर थियरीज, क्रिएट न्यू थियरीज, मेक मॉडिफिकेशन इन थियरीज, एंड वंस द थियरी इज देयर, द थियरी मेक्स प्रेडिक्शन एंड न्यू एक्सपेरिमेंट्स आर डिजाइन्ड। Alright, so that is wave particle duality. Let's go ahead and see what other experiment is there in our presentation. Alright, so which experiment taught us wave particle duality? Photoelectric. Okay. Next is photoelectric effect. This is, you know what is AE? It is Albert Einstein. Yeah, and it said that again some experiment was done. On the left you have Hertz, and he was doing an experiment to verify prediction from Maxwell's theory of electrodynamics. And the Maxwell theory is that if some kind of oscillation of charges takes place, it should make electromagnetic waves, and that electromagnetic waves should travel in air or in vacuum. Now, once that theory was there, and the theory was not developed for this emission of radiation. The theory was developed to understand theoretically the normal experiments which we do with charges and magnets. The magnets repel, the magnets attract, the charges create fields, and then if you change magnetic field, then some kind of electric field is created. To understand all those electricity and magnetism phenomena, Maxwell had developed a theory. But then the theory predicts, from the calculation of that theory, it comes out that okay, if a charge is oscillated with large frequency, then it should emit, the theory says that it should emit electromagnetic waves. And once the prediction is there, the experimentalist is on work. And this Hertz creates the experiment, and let me talk about a little bit of that on the board. Okay, so the experiment was to test something else, but then finally, together with that, Hertz observed something else, and that the radiation which is coming from this oscillating, here is the oscillating charge, a dipole in fact, in which the current is sent and the current is oscillating, and from the radiation, if there is a metal, and this radiation falls on it, then some electrons are emitted from here. The experiment was not designed for this. That's the beauty of experiment. आप करने को कुछ और जाते हो, और जो करने जाते हो वो तो होता ही होता है, और आपको एक के साथ एक फ्री कुछ और भी निकल करके आ जाता है अलग से. So when Hertz does this experiment to test, this experiment is designed not for this particular thing. This was designed to test that Maxwell's predictions, Maxwell's theory prediction. And what was the prediction? That there should be an electromagnetic wave if this charge oscillates here. For that he has designed to catch, to detect, to study if at all there is an electromagnetic wave is coming in the laboratory where he is making all these dipole oscillations. But then during the experiments, it just comes out that this radiation, when falls on the metal, electrons are emitted. So that is how from the theory the experiment is coming, new experiment is coming. New phenomena is observed, and where it starts in this theory, the prediction of theory. The prediction of theory is not for this. The prediction of theory was something else. But still, to test that prediction, this experiment was designed, which also yielded this photoelectric effect. So that is Hertz, and on the screen you saw that the middle, that is Philip Lenard. He takes it up this particular piece of this part of the experiment, Hertz experiment. Hertz के experiment का ये जो हिस्सा अलग से मिल गया था, उसको पूरे एलाबोरेशन के साथ, पूरी उसके लिए अच्छे apparatus बना करके अलग से उसी को स्टडी करने के लिए लेनार्ड ने काम किया, और वहां से रिजल्ट्स निकले फोटोइलेक्ट्रिक इफेक्ट वाले एक्सपेरिमेंटल रिजल्ट्स. और उसकी व्याख्या करने में कई साल लगे, लोग तरह तरह से व्याख्या किया, लेनार्ड ने भी व्याख्या किया. And after finally the Einstein's photon theory of light, that could explain this very well. Okay, so the photon theory it gains strength, although there were many other things which led to that photon theory. But yes, this experiment, photoelectric experiment, is also it's giving inspiration for creating that theory. तो इस तरह से करके वो सारी चीजें जो हैं वो चलती हैं. Let's see some more. After photoelectric effect, right, neutrino. Which experiments led to the proposition of neutrino? Now, neutrino is something a very, very wonderful, very, very exciting material, particle. We call it neutrino. न्यूट्रॉन अलग है, न्यूट्रॉन अलग है, प्रोटॉन न्यूट्रॉन वाला न्यूट्रॉन, दिस इज न्यूट्रिनो. और ये न्यूट्रिनो जो है वो बिल्कुल कोई चार्ज नहीं है, इसमें मास इतना कम है कि कुछ पूछो ही मत. जो बहुत समय तक, अभी हाल तक, समझो 2 दशक पहले तक, 20 साल पहले तक, till the end of 20th century, we all believed that neutrino has no mass. It's a massless particle. But once again, the experiments showed that no, it does have mass. From the electron, if you compare, it's almost 500,000 times less mass than the electron. But it is there. This was again an experimental finding, and people are still developing theory to understand this mass of neutrino. Okay, now this particle, this neutrino, is very exciting, very interesting in the sense that it has no mass, or extremely low mass. It has no charge, and it does not interact in any significant manner with the material. If it falls on this board, if neutrino falls in this board, it will not interact, it will not be deviated, it will not change its path because of the board colliding with the board. The neutron will just go in straight line. Very, very extremely weak interaction. Sometimes it takes place. Very, very weak. So, almost all neutrinos which are falling on the board are crossing the board. And not only board, you can have concrete walls. It will penetrate the whole wall and go on the other side without being deviated. It can penetrate the whole 12,800 kilometers of Earth's diameter. It can enter the Earth from one side, and then it can come out of the Earth from the other side. Radius of the Earth is 6,400 kilometers. So if it falls along the radius, then it will cover this entire 12,800 kilometers without being deviated. And therefore we don't see neutrino, because it doesn't change anything. It does not interact. But then neutrinos are all around. That is another beautiful aspect. The protons, neutrons, electrons, they are not everywhere in that much quantity. But these neutrinos are created every moment in the sun. In the sun, when hydrogen fuses to helium, in that process some neutrinos are created. And once they are created, they start moving in all directions. So the neutrinos which are created in the sun and which head towards the earth, आप सोचिए, सूरज से बहुत सारे न्यूट्रिनो हर क्षण पैदा हो रहे हैं. हाइड्रोजन का हीलियम बन रहा है और साथ में न्यूट्रिनो भी पैदा हो रहे हैं, और वो सब चलना शुरू कर देते हैं सब तरफ. तो जो धरती की तरफ चलते हैं वो धरती पे पहुंचते ही पहुंचते हैं. तो आप कभी भी खड़े होगे धूप में और सूरज की तरफ आपका चेहरा होगा, तो आप सोचिए आपका जो फ्रंट पार्ट है बॉडी का, जहाँ धूप पड़ रही है वहाँ पे ढेरों न्यूट्रिनो आपके ऊपर पड़ रहे हैं, और आप रात के समय भी न्यूट्रिनो से बच नहीं सकते। सूरज अस्त हो चुका है, धरती के दूसरे साइड चला गया है, हम दूसरे साइड हैं, हमें हमें रोशनी नहीं मिल रही है सूरज की, रात है, लेकिन सूरज अभी भी हमारे लिए जो रात है अभी भी न्यूट्रिनो एमिट कर रहा है। और इस कारण से वो जो न्यूट्रिनो है वो रात को भी चल के धरती को क्रॉस करके अभी भी हमारे शरीर पे आ रहे हैं। अगर हम सोए हुए हैं तो हमारे पीठ के साइड से न्यूट्रिनो घुस रहे हैं और पेट के साइड से निकल रहे हैं, हमें पता नहीं होता, हम चैन से सोते हैं। Because neutrinos almost do not interact with the body, and hence we are all getting these neutrinos are hitting our body and penetrating our body and come out from the other side, and we are not harmed. So that is neutrino. But all these neutrino, we have a lot of theories, wonderful theories, and people are still working on understanding the behavior of neutrino, and the theories are being created. So if we look at the presentation, then it all started with an experiment on so-called beta decay. Right? In beta decay, some radioactive materials, some protons are converted into neutrons, and neutrons are converted into protons, and electrons or positrons are emitted. That is called beta decay. And then the study of beta decay, experiments on beta decay could not be understood by the existing theories. And this experiment on beta decay, the results of beta decay experiments, that led Fermi to propose that there should be a particle like neutrino which is created in this beta decay. And that is how we came to know about neutrino. And then all those theories, and there are three kinds of neutrinos, and there's conversion from one kind to other kind, whole lot of theories are developed. But all this theory came out from the experiment on beta decay. A new theory comes up to understand the experimental results. And once we understand a little bit of neutrino, then new experiments are designed to know more about neutrino. So from the theory to the experiment, from the experiment to the theory, that connection goes on. So I believe I have given some examples. Right, yeah. So this is the detection of neutrino was in 1956, got Nobel Prize 1995. In 1934, this existence of neutrino was suggested by Fermi. So it takes long time sometimes. Yeah. So okay, so I think I have given some examples why experiments are important. If you do not understand experiments, if you are not able to perform experiments, if you are not familiar with how experiments are to be done, then possibly you won't be able to contribute to the development of physics with that intensity. All right, and therefore it is necessary for the development of science or physics that we perform experiments, understand theory, comfortable with theory, comfortable with solving equations, at the same time comfortable for doing experiments. So ये जो दोनों का रिश्ता है एक्सपेरिमेंट्स और थ्योरी का, ये अपने को आना चाहिए। और इसी के लिए सारी जो नेस्ट की कवायद है, ये इसी के लिए है कि हमारे स्टूडेंट्स में स्कूल के समय से ही, कॉलेज के समय से ही ये कल्चर डेवलप हो, एक्सपेरिमेंट करने का कल्चर डेवलप हो, एक्सपेरिमेंट करने की महत्ता समझ में आए। We should all understand the importance of doing experiments, performing experiments, designing experiments. Designing experiments is even more important. already designed experiment you are performing, that gives you a skill of doing experiments, and you know many things which are involved in experiments. But if you are to design an experiment for a certain objective, it's even more useful. So to develop that culture, we are doing this National Anveshika Experimental Skill Test, and those who have not registered, uh, do register. We have a discussion forum there. Lot of students, thousands of students who have registered, they are putting their questions on the site, and others are replying, and discussions are going on. I have also replied some of the questions. So you register on this naest website, participate in all our activities. On 20 in the end of May, last week of May, we will have this first round of this test, national competition. All those informations you have on the website, the scholarships, the prizes, and the benefits, all those things are there. So thank you very much for listening to me in this webinar. Do join next webinar, same time, same day, Saturday next week, and understand about the relativity of Einstein. Thank you very much.